My name is Mansu Kim, work at Imperial Solutions.
Emphasize more from S generative to CATIA the workflow.
Nice, right? But and
Right,
also
right.
remember that this is not only the result, it's all including the structures. So you can see here I mentioned breakdown of the design because the first step when we having a project, the designer usually design itself, they doing some designs, but not the how to make output, focusing on how to make output, right? But here in CATIA, we can build the process like how to make a box. So you can start from the point and line and surface and box, or you can create the box from the start. You know, there's many ways to creating the box. So therefore, how you will capture the design intent, the box will later on how the shapes how we're going to change, you know. So it depends on your ability, changing ability in demand of a design. So we build the structure differently. So even you made the simple box, there's many way. It depends on the user. User will apply them differently. So that is the the power of building a structure by CATIA, and you will achieve each steps. Okay. So for understanding of design script, I prepare a little bit things. So first steps we need to have a mesh, right? So mesh because the mesh is important, of course, for the designer as well, and also you need to think penalizing depends on the mesh types. The penalizing types will impact what kind of panels you will apply on later on. So those are all related by cost. So you see here, for example, here's I explain about the panels. So you see here the mesh is like a very complex mesh, but they build as a flat. So it's much, cost much reduced. Or sometimes they use the one-way curve panels, and sometimes they use the two-way curve, so which is the most expensive manufacturing method. So it depends on what kind of panelizings you will do. So the shapes of the buildings will looks differently, right? So what kind of material you use? For example, glass. It's more expensive if you use the glass, like covered glass. That's why they more prefer like a flat here, for example. So those are when I just combining them, the stuff looks like this. Like a mesh type when I according flat, then one-way curve and two-way curve, double curve. So there's mesh designing some stuff, what kind of the block study after then penalizing. But even penalizing, you can do two-way curve, right? Something like that. And then the stop if from the one-way curve they create, and it will also can be flat later on. The two-way cover also shapes will be unique, but sometimes they will apply the penalizing as a two-way, or sometimes they apply the flat. So it looks really different. What kind of design you will going to achieve. So you need to think both in same time, not only the mesh, but penalizing. So therefore you will know some cost, how those are, and how shapes will different act. And
But that's interesting because
yeah.
when we if I may add on, when we do one-way curve, we can do, of course, we can do literally curved, one-way curved panel,
Mhm.
but at the same time, we can also using planar surfaces to approximate the one-way curved geometry quite easily.
Yeah, yeah.
So, so they are still choices. Yeah.
Yeah, right. So one way curves is kind of a foldable surface, so foldable geometry, right? So one way curve can I mean unfoldable geometry. So it's
Unfoldable, yes.
unfoldable, yes. So it's more easier to manufacturing than the two-way curve panelizing. There is a very unique, but it's hardly applied the manufacturing process because not all manufacturing company have this kind of ability, right? Therefore, the cost will increase, then only the specific company can do it. But even your mass like unique complex shapes, two-way curve, but by applying different penalizing, so it's able to in manufacturing with lower costs.
Yes.
Okay, so those kind of things. And if I explain a little more about the breakdown of the design. So when you starting design, uh, you will get some information or conditions, right? How to design. Uh, then those informations, you will do some study, design stuff or something. And then you will make a little bit detail and a little bit more detail and then more detail than for making the output, right? So those are exactly you can achieve in CATIA by your process of the design, okay? So then when you change some concept, so those are effect to until the result because it's parametric and connected. Therefore, the steps are really important to know what you will gonna achieve for result. So we are usually doing this work, helping this work to how to making a result. So when you make this very well, when you change the informations, the result will be changed. So those are, we usually call that template, right? So parametric modeling itself, it can be a template. When you change and if there's no error and will update well, so that means it works as a template as well. So how to make this kind of structure without the errors, of course, is crucial when you change something parameters. So we will look one by one. And then when I mentioned about the template, maybe step of the designs like this for facade example. You will doing sorry if I'm wrong, so you can always improve me, okay? So maybe
Oh, okay.
we will start from the mesh modeling and study some stuff. After that, we will create some grid modelings. So this grid is not for the plain grid. This grid for panelizing the exterior. Okay, and you will
So
do.
we do just for somehow the people around me they like to call wireframe the grid.
Yeah,
They like to
yeah,
call the
yeah.
grid a
Wireframe.
wireframe.
Yeah, right. Wireframe, and it's sometimes called that skeleton. So,
Hmm.
and from there, so you will going to create some details stuff, right? So each process, or process is already you can call the process, but each small process have a activity like a small process. What you are going to get and what we are going to out. So you need to build
Hmm.
from here to here. So each steps have like that. For example, the output of a mesh modeling can be an input of this step of creating the wireframe, right? Then the result of a wireframe can be an input of the detail modeling. So those are
Yes.
connected like that. So you can build the template only for this, or you can including the template like this. So those are just matter of where you will going to create it as a template treatment. So for example, here, when you created some detail designing template, so you have some different parameters and achieve some different detail design, like height or wide or some things. You can see in same time later on easily, right? Or you can create a template like until here. So changing the wireframe the distance, for example. So all those are having a different distance of a wireframe and achieve the for details as well. So those are stuff you will going to step by step to achieve. And here's maybe I can mention a little bit more. You no need to, usually people confuse somebody doing a detail designing, but the model inputs are not parametric, like wireframe. I import from rhinoceros. It's not parametric anymore. So can we still achieve? Yes, of course. You just ignore them, and you can start from here. You see the CATIA actually, we speaking many times like parametric modeling, but CATIA you can do without the parametrics as well. There's many ways achieve. So also I will introduce one by one. So it's good.
So just a note, please. So especially for the architectural firms, I would believe most of the firms would like to really make this the massing, the wireframe, and the detail, the three stages working together, because that really show the power of CATIA. But because Mensu is right, you can plug in the template in different phases. When we say massing, maybe more concept, and then when we say wireframe, that can be more like a schematic design. Then when we say detailed design, that would be more related to the late design development, the so-called DD process, and even the early CD process. That would be that type of level of detail an architect firm will be looking for.
Great. So, and the one of the structure recently what I have done, for example, this is the schematic process. Of course, each small process will including a lot of process inside, of course, but those entire. I think you watch this video, right? For instantiate the wall template, for example. The LinkedIn.
Also, instantiate is the CATIA term, and in other program we may say populate. I think it's quite I think it's quite unique. People say instantiate in the CATIA platform more often than other people.
There's a lot of difference, word.
Yeah.
In
No, I just like to mention because I hope other people when they see this, the video you are making, then they can pick up to get the idea across.
So I will just show you just important. So in this template, we are not don't care the input how he made, but or there's conditions or and with openings without opening. So the instantiate them. So the template apply to the template include some program template including some automations for the number of the numbers changing automations. So, so template is something like that. So that template, like when I create a schematic process structures, look like this. So product inside the product you have a skeleton and some knowledge specifications for automations things, and later on each component will achieve for detail work. So detail work, this came from the template. So these templates came from like this, like that. So those are, the schematic concept, how we going to build the model, right? But this is a little bit complicated for explain, but I just bring it to explain you what is the process structure look like.